We're going to continue our discussion about sequences by talking about partial sums of sequences. So for example, if I wanted to know the sum of the first 5 terms of a sequence or the sum of the first 20 terms of a sequence, um, there are ways to do that. We're going to talk about sort of brute force doing that and how to use our calculator today. So when a problem wants you to find the sum or the partial sum, they often use the symbol sigma. This is sigma. It's a capital Greek letter, sigma, and it always stands for sum when it's used in mathematics. So if we wanted to find a sum, we would indicate the sort of functional definition right here. So maybe n squared plus 1. And then over here on sigma, we would indicate what we would want you to start with, start with n equals 1 and go to something like 3. So this would say, find the sum of the terms from the first term to the third term of the sequence defined by n squared plus 1. And so that would mean, um, sometimes I like to write them. N is going to be 1, and then 2, and then 3, because 1 to 3, 1, 2, 3. And then I plug them in. 1 squared is 1, plus 1 is 2, plus 2 squared is 4, plus 1 is 5, plus 3 squared is 9, plus 1 is 10. So this notation is asking for this work to be done, and that would make 17. So the answer would be 17. Okay, so we have the sum of the terms of the sequence 5n minus 7 from the first term through the fourth term. So that would mean the first term, the second term, the third term, and the fourth term. So the first term would be plugging in a 1, 5 minus 7, negative 2. The second term, plugging in a 2, 10 minus 7, 3. 15 minus 7, 8. 20 minus 7, 13. This sum is 21, 22. Let's see. 1 and 8 is 9, 22. Close. Okay. The sequence defined by negative 1 raised to the nth power divided by n. We want the sum of the first 6 terms. So 1, 2, 3, 4, 5, 6. So if n is 1, that would be negative 1 over 1. If n is 2, that would be positive 1 over 2. If n is 3, that would be negative 1 over 3. If n is 4, 1 over 4. Negative 1 over 5. Positive 1 over 6. Common denominator, I think, is 60. So we have negative 60 plus 30 minus 20 plus 15 minus 12 plus 10. And we get, I believe it's negative 37 over 60, if I did the problem right in my notes. It doesn't have to be that we find the sum of the first some odd terms. It says find from term 3 to term 6. So it could be the third term, the fourth term, the fifth term, and the sixth term. 3 minus 2 is 1, squared is 1. 4 minus 2 is 2, squared is 4. 5 minus 2 is 3, squared is 9. 6 minus 2 is 4, squared is 16. That looks like 30 as a sum. It could be that the index is not n, but some other letter. So from j equals 2 to 7. So we want the second term, the third term, the fourth term, the fifth term, the sixth term, and the seventh term. So that would be negative 4 plus 3 is negative 1. Negative 6 plus 3 is negative 3. Negative 8 plus 3 is negative 5. Negative 10 plus 3 is negative 7. Negative 12 plus 3 is negative 9. And negative 14 plus 3 is negative 11. If I add all those up, let's see, negative 4, negative 9, negative 18, negative 19, negative 29, negative 38 it looks like. Although, I may be wrong. It may be negative 36. Check me on that one. Here's an interesting one. We want from the third term to the ninth term. So we want the third term, the fourth term, the fifth, the sixth, the seventh, the eighth, and the ninth term of 12. So we have 1, 2, 3, 4, 5, 6, 7 sets of 12. So that's 84. I know that's right. This is interesting. You might have wanted to do this without writing it out. And if you thought that from the third term to the ninth term was 6 terms, we can see 1, 2, 3, 4, 5, 6. It's 7 terms. So from the third term to the ninth term, don't just think that we're subtracting to get the number of terms. There's actually 7 terms in there. Last thing, if I wanted to use my calculator, suppose it's just too big a problem. Like I want from the first to the 20th term of this polynomial n squared minus 4n plus 2. There's just no way I'm going to do that longhand. So the calculator has a setup, sum of a sequence, and then what goes in here is our function. What goes here is the variable. So if you choose to use n or j, I tend to use x so that my variable actually is x. And then here we write, where did the index start? In this case, it started at 1. But in some of our cases today, we started at 3 or something, 2, something else. And then where does the index end? In this case, it'll be 20. So I'm going to go out to my calculator. It is under list. So it's the second function of statistics. The second function of statistics is list. And if we arrow over, we have under operations, we have sequence. And under, oh dear, second function of list. Under math, we have sum. So I would put sum, sorry about that. The second function of statistics is math, number 5, and then go to the second function of statistics under ops, 5. So it's the sum of a sequence. What sequence? It was, and I'm going to use x because it's easier to get to, x squared minus 4x. Oh dear, my calculator's having trouble. 4x plus 2, and then a comma. Comma is right above 7, comma. The variable I used was x, not n. Another comma. My index started at 1, and then a comma. And my index ended at 20. And even though this problem would be horrific for me to do longhand, my calculator says, okay, the answer is 2070. Okay, give it a try.